as we go to a weather museum today in Norman, which is the tornado capital of the world.
And after that, we get to go see a spot that is on diners, drive-ins, and dives, and check out how good their food is.
And you don't want to know how long it took to say that.
And we are here today with
Lauren
and
Gwen.
Obviously, we need a way to communicate weather to the public. It is very important. You see it on a day-to-day basis. So how that happens is you see the meteorologists stand in front of a green screen just like this. And they usually will either have a screen that is off to their right or their left, and sometimes even out in front of them so they can look at their audience and say exactly what they want to say. They will create all of their graphics themselves. But yeah, if you guys want to go ahead and try to give it a
I left
whirl.
my green shirt at home. Now I can't be invisible.
Oh, yeah.
And then also there's this.
Kind of the invisibility cloak with Harry Potter.
Does it work?
you see what this is very useful for here. You stand there. You stand there. And then
By myself. I'm all alone and it feels like something's poking me.
The first tornado forecast actually came from Tinker Air Force Base. That's about 10-15 minutes north of us, back in 1947. Our founder, actually, Doug Forsyth, helped to work on this device. This is the Norman Doppler radar. One of these discs would actually hold about 15 minutes worth of data.
okay.
And it looks
Is this the one that was put in 1970 something?
around that time, yeah.
Yes.
Okay.
And it was used up until about 2002.
That was installed in Norman. My dad talks about seeing the original Doppler radar sitting in the middle of the football field.
That sounds
That is
about
so
right.
funny.
That sounds about right. So this is kind of what the output looks like that we're familiar with today. So this is classic reflectivity that we see. So we see that classic hook echo shape. So that was the radar scan from the El Reno tornado. So all this pink color that you're seeing here is what they call the hail course. That's where all the hail is located in the storm. And then that hook right there, they call that a hook echo. That is where your tornado is going to be. So that was a tornado that was on the ground at the time, and that is the warning box that they issued for this storm. And then over here, you're looking at Doppler velocity. So that's showing which way the winds are moving in the atmosphere. So all of this red right here is showing winds that are moving away from the radar site, and all of this green is showing winds that are moving towards the radar site. So theoretically, if they call this a couplet. So when you have these really bright colors that are next to each other, you have really strong winds that are moving this way away from the radar site, and really strong winds that are moving towards the radar site. So you can basically see that rotation in the atmosphere. So that is definitely a very helpful tool for meteorology.
Yes, and before we saw that, we had this, which is about.
Oh
this is
my
only-
goodness.
This big packet is only a day's worth of weather.
Oh wow.
Actually, look super duper close. You can see where the meteorologists would mark in pencil of that
Kind of their
stuff. So
annotations.
it's pretty neat how far we've come from this to just seeing the reflectivity.
Yes, that was before we
so.
had basically computer screens.
Yeah, that is a huge step.
Yeah. So the other thing with that, the only way they were able to get this data is if they traveled all the way down to Houston for that. So poor little intern basically had to drive all the way down to Houston just to get this data.
Right, because
So-
at the time, we didn't have a computer here that could process all of that data, so they would have to go to NASA in Houston to get all that processed. So.
It was definitely a long
So
process.
was that this machine was outputting data, they were taking it down to Houston, or was this?
Right,
Did
they would send it down.
Okay.
Yep.
So that would, this
Right
is
here.
the device that they would use for this.
Oh, good.
Yeah.
The gumdrops.
Over here, we're basically talking about some of the research that OU has conducted.
Okay.
So this is actually a part of a radar from one of the trucks. So you can kind of see it's damaged. It was actually damaged by hail. So that's what the truck actually looks like. Now,
What's the range on something like that?
usually with Doppler radar, about 100 miles, but you
Okay.
definitely don't want to get too far away from the radar site, because the way that radar basically works is the beam kind of points up in a diagonal up into the atmosphere. So the further away that you get away from the radar site, you're looking higher up in the atmosphere. And obviously we're down here on the ground, so you don't want to be looking too far up into the atmosphere. There are several different radar like holes that they call it around the US, where they don't have a radar site that kind of like reaches that area. The radar sites are kind of too far away from that area, so sometimes weather information can be missed in that area because they don't have coverage in that area.
Is that what the trucks are for, or are the trucks for a little bit more of a precise view of a known weather event?
So this is more so done for specific research. There's a lot of different areas of research that they're kind of conducting with OU right now. We actually still don't know how tornadoes are formed. So we know the ingredients that are basically needed for tornadoes to form, but sometimes you can have all those ingredients and a tornado forms, and sometimes you can still have those ingredients and one doesn't form. Or vice versa, you can not have all the ingredients and then the tornado forms. So we're still trying to figure that out. So it's a very interesting process. Now, there's also other things up in our atmosphere like birds. You have butterfly migrations, bats at night, and that actually shows up on radar. So there's actually a process called dual polarization, which sends out two beams, one in the vertical and then one in the horizontal. And that basically gives you a 3D image of what you're looking at, and it filters out all of that stuff that's not weather related. This is the reflectivity that I was talking about earlier, and then that's the velocity that I was talking about.
Okay. So that shows that the wind's moving away and towards. Is this the same colors as that?
Yes.
Okay.
It is. So you also have something called correlation coefficient, and you might have heard something called the debris tracker when you're like listening to the news. So that's basically what that is. So it's basically scanning our atmosphere and saying all of the raindrops, hailstones are roughly the same size in the atmosphere. But when you have a tornado on the ground, it's lifting up
Big reflective chunk.
Yep. When it hits houses, 2x4s, bricks, and all of that stuff, it's a lot bigger than a raindrop. So it's basically saying that there's debris that's being wafted up in our atmosphere. And you can also see something called hail spikes, because obviously hail's just a little bit bigger than raindrops. So it kind of shows where the hail is in storms as well. So it can definitely be a very useful tool for meteorologists.
Especially with that really big hailstorm we had the other day.
Oh yeah, we've seen a few. Lawton a few weeks ago had some pretty decent sized hail, but yeah, we've seen some pretty decent sized hail. But we also have a cast, second largest hailstone that we can show you here in a second.
Oh wow, okay.
So I don't know about if you guys have heard recently on the news, they've been saying like DVD and CD size hail. So we actually added this recently. They're very creative with their names now. You'll hear kind of various things, but this is just kind of like the generic
size
like
reference
meteorologists refer to when sizing a hailstone, so people can have an idea of what is coming.
Something common that people have handled: nickels, dimes, quarters,
exactly.
golf balls.
When you're doing that stuff to public, you want to make sure like everyone can understand is on the same page. So.
That is actually a cast of the second largest hailstone that fell in Kansas.
Wow.
Back in 1970. The largest was actually in Vivian, South Dakota. It weighed about 1 pound and 15 ounces. Pretty hefty.
Yeah.
Do you know roughly how big it was? Like,
I would say it was like that big, just a little bit bigger than that one. That's actually the cross section right there of that hailstone.
Oh gosh.
So you can kind of see it was formed in layers, because that's exactly how hailstones form, with the updrafts in these storms. Because it's really, really cold up in our atmosphere. They start as a raindrop, they freeze, they eventually fall, and the updrafts lift it back up, and it's just a big cycle until they get too heavy and they fall to the ground.
it amazes me that that thing can be caught in an updraft.
Exactly. So it just shows how powerful these storms are. So over here we're kind of talking about like the early stages of forecasting. So this device right here is called a radiosonde. You're more than welcome to kind of hold it. This is what they attach to the bottom of weather balloons.
That's light. It's
very
what,
light.
a couple of ounces?
Yeah. So they kind of make it out of styrofoam because they want it to be light because it's lifted up by a balloon. Now, a balloon is roughly the same size as this table. So they're pretty decent sized balloons. And then they want to make it out of cheap material because they know they're probably not going to get this device back. It's probably going to land in like the middle of a field somewhere. And if somebody does find it, they actually do have an address that's attached to it so they can send it back to NWS.
Okay.
But they release it twice a day at NWS Norman. One at 7 a.m. and then again at 7 p.m. And they change it according to.
What are they made out of?
So they're just made out of rubber, like normal
Okay.
balloons. So this is an old balloon that kind of popped. It's a little bit smaller than obviously when it's blown up. It looks a lot smaller than when it's blown up. These are just some of the older radio sounds that they used to use. Those are made of cardboard, and so it actually radios the data back to them. They have GPS in there so they can track it. They used to actually have to track these balloons with their eye. So that's what that device was actually used for right there. So this is a Thaddeus. So they would have to actually look through here, and they would have to track it across the sky for about 2 hours. So if they lost the balloon in the sky, you lost it. They don't get the data. And then this device is kind of the same as well. I'm sure you guys have seen the hurricane hunters. This is a drop zone. So this is what they actually drop into hurricanes. So there's a little parachute that kind of comes out the top of that, and you're welcome to hold that as well. Obviously heavier than a radio sonde.
Noticeably.
They're basically wanting to see what the hurricane is doing, if it's strengthening, if it's weakening. So lower pressure is kind of associated with higher strength hurricanes. So if they kind of see that the pressure is lowering, they know that the hurricane is kind of gaining strength. It also needs warmer waters to be able to sustain its life.
So it probably has a thermometer and a barometer in it?
Exactly. Exactly. Behind you are just some different devices that they use to help kind of communicate this with the public for military purposes and other things as well. You're more than welcome to try this out. You can try Morse code here. That's how they used to have to transmit weather.
I played with one of those in video games.
So
Noisy thing is fine.
they kind of realized that that wasn't really a feasible option if they wanted to transmit weather on a faster rate, and not everybody knows Morse code. So they kind of transitioned to this. This is the teletype machine. So this was a real tornado warning that they actually sent out. So the meteorologist would basically write out what they wanted to say in the tornado warning, and then that was the actual warning that they sent out, and that's a picture of the tornado. So the fence is kind of blocking it all.
Holy cow.
Yeah,
I'm
no,
not
that
sure
was
if
a
it'd
big
pick up
tornado.
on camera, but that's the tornado.
Yeah, kind of the glare a little bit. But that was back in 1979. I believe we called that Terrible Tuesday.
That would be a rough Tuesday.
That
would be a
terrible
rough Tuesday.
So this is basically a fax machine. So they used to actually have to hand draw their surface maps. They needed to know where their high pressure systems were and their low pressure systems were, because they actually used to have to mail these maps, which obviously once you mail them, old
It's
news.
no longer
It's
relevant.
no
Yeah,
longer
yeah.
relevant. So that they use basically a fax machine to kind of do that, and it would go line by line and then radio it out to wherever they wanted to send it. And then this device behind me was actually donated by the National Weather Service. So this was used there. I believe it was used around the 80s. When this was
Up
used.
until early 2000s.
Are they IBMs?
This is just like another example of technology. They had to build it where it could last. So a lot of the stuff you'll see here at the museum, they used for many years. So.
And with computers back then, you remember if you kept them on for too long, it would actually burn into the screen. So I love pointing that out to kids because kids are like, "What? That happened?" Like, because they're so used to technology that we have today. But you can actually see the little lines that were actually burned into the screen.
yeah.
They just left it on too long.
Left it on for too long. May 20th, 2013 tornado. So we actually
remember
just passed the
that one.
10-year anniversary of this tornado. That was actually the last EF5 tornado that we have seen.
Oh,
We
wow.
have not had an EF5 tornado since then. So this car was actually owned by a nurse in the Moore Regional Hospital. She was taking shelter at the time. She was fine. Unfortunately, her car was not.
I think that's called a write-off.
Yeah.
That's really useful.
That's I see a slight body job has happened.
Yeah.
Some light denting.
You have the steering wheel snapped in half. Yeah. It unfortunately hit 2 elementary schools. And there's actually an elementary school chair that's actually stuck in the back of the car. So if you actually go around to the back of the car, you can see that.
Oh gosh.
We evacuated in front of this one. I said we
Holy
evacuated
crap.
in front of this one. I was living just off of Indian Hills at the time.
That would have been a little too close for comfort.
That's
And that's actually
Wow.
a door from a different car. Yeah.
I hadn't quite recognized what that was yet.
Yeah. So this is also just to show that you should not be in a car during one of these storms. Because they can almost act like an airplane wing once that air kind of gets underneath your car, especially lifted vehicles. That air can get right underneath your car and just toss it.
And that's the same reason the underpasses are dangerous.
Yes, a lot of people, that's actually a big question that we get is, oh, well, is it okay to just stop under underpass? You're a lot safer trying to find a building with like a foundation, and obviously roof and not as many windows, but obviously you can't be too picky when you're in a storm like that. You just want to get in a structure with a foundation. But if you do happen to find yourself in a tornado warning and the tornado's literally passing in front of you, you literally can't go anywhere else, they either say to tuck your head, definitely want to protect your head, or you have to get into like a lowest point that you can find, like almost like a ditch, and then cover your head as well.
Yeah, that would not have been very survivable. At least I wouldn't have wanted to try it.
No, I definitely would not want to be in that situation. This tornado was actually on the ground for about 47 minutes, and at its widest it was 1.3 miles wide. Big tornado. So this is just some things that maybe people tend to forget to put in their emergency kit. Something as simple as a helmet or even cash, because if your power goes out, you can't use your credit card or debit card anywhere. So you want to make sure you have cash on you. And maybe some snacks, a lighter, if you have any candles or anything, and just maybe some Advil or medications that you might need if you kind of have to grab it and go really quick.
And this would probably also include like your dog leash and make sure he has his tags on him.
Exactly. So people can still kind of customize it for their needs and things, but like even some extra batteries for a flashlight if your flashlight goes out. This is actually a weather radio. That's the exact one that I have.
Me too.
Yeah, that will definitely wake you up at night. It will, if you have a warning in the middle of the night, it will start kind of blaring at you saying that there's a warning in your area. It will also tell you if there's watches, but you can turn that setting off if you only want to know if there's a warning in your area. But you can set it to your specific county as well. So,
If a tornado is headed towards you, what do you do?
so you want to get to your interior-most room. You want to make sure there's no windows, no doors or anything. Whether that's under the stairs, in an interior bathroom, in your basement, those are kind of the main areas that you want to be in. So behind me is actually a plane that they used to fly in the thunderstorms. Yeah, so they wanted
That'd
to
be a
collect more
job.
information on hail. So obviously when hail falls to the ground, it either melts or it breaks into a bunch of pieces. So they can't exactly study it very well. So all these little dents in the plane are actually from hailstones from when they were flying up in these storms. They actually had it to beef this plane up a little bit.
I'm
So
not
they
surprised.
Yeah. So they added some extra layers of steel on the outside of the plane. They also added little individual panels on the outside of the plane. So they could take the impact of hail, because obviously when you're flying through these hailstorms, hail is gonna hit you. Obviously they don't want their window breaking, because that would be absolutely terrifying. So this is K-band radio. So this was actually in the back of the plane. You see how much room it really took up?
Over here.
This is different than Doppler radar, than the one that I showed you earlier.
Okay.
So this is on a much shorter range, but it gives you a more precise image of what they're looking at. There's only one pilot in there at a time, which could...
So your first time being in the plane is flying the plane. So
Yeah, I'm sure they
That
had
would be exciting.
more practice with
I was gonna
it.
say,
Right,
I
right.
assume they
You
used
train,
a trainer.
oh yeah,
yeah.
They were
Prior
trained,
to-
but like
The fir-
actually going in it is their like first time flying. So.
Over here, we have our little sandbox. This will just kind of show kind of how watersheds work.
Okay.
So water is always going to try to move to the lowest elevation that
that's
it can.
cool.
Yeah.
So when you move it around, you can actually try to
Yeah,
create
this
your
is one of our
own
interactive
watershed.
exhibits that we have.
Yeah, the kids.
The kids
love
love
this
this. But it's yeah.
Yeah, so the elevation and topography will actually change as you kind of swipe your hand through it.
So
And it's a great way to learn about topographic maps.
yeah,
Exactly.
exactly.
And so what I'm noticing the different colors. What do these mean?
So the blue is where the water is. It's kind of at like a lower
I
elevation.
have water on my mountain
Yeah.
and none at the bottom of my lake.
Yeah, and then the higher you get, you kind of see these more reddish tones.
Okay.
So the red is kind of the higher elevations, and it will actually turn white once you kind of reach the.
Almost a snow cap.
Yeah.
Yeah, that would be the snow. Yeah, snow cap.
always fun.
Yes,
That
very
is-
fun.
that
It's
is
super
delightful.
fine.
Yeah, it's
sand.
very,
Yeah.
it's almost like
So,
glitter. Like it's
yeah,
gonna
it
get
is,
everywhere
like-
and you can't like
You can't
it
get
off.
rid of it.
No, you can't.
I could sit here and
And
this
no,
makes
yeah, you
this
can be
makes
here for like a
sandcastles.
long time. Yeah.
Oh yeah.
Little water sandcastles. See
Yeah.
what it would do with that.